Hello, YouTube. Welcome back. What are we doing today? Chapter 1, Section 6. Everything you need to know about linear equations, equations of lines, y equals mx plus b, that stuff, okay? So here's for our first question. Can you find the equation of the line through the points a and b? A is at 1, 2, and b is at 5, -3. So the first thing we did was we found delta y and delta x and the slope. And then we used the slope-intercept form. I'm sorry, the point slope form. In other words, if you plug in any point you know, like in this case, 1, 2, and the slope, you got the equation of the line. And if you want to get y alone, mx plus b form, you could do that. So take that equation and solve for y. So m is there. Okay, so here we go. So, whoopsie, what did I do? I did something wrong. Oh, var y. I have to var y if I'm going to use y as a variable algebraically. In other words, in the solve command to solve for y. So there you go. All right, so what's delta y? It's 2 minus -3. Remember, how do you subtract? You never do. It's 2 minus -3 is you add the opposite. 2 plus a positive 3 is 5. Over 1 minus 5 is -4. So 5 over -4 is -5/4. So if you write y minus y1 equals m times x minus x1, you got y minus y1 is y minus 2. X minus x1 is x minus 1 times the -5/4. You could have used this and put a -3 here, so y plus 3, and put a 5 here, so x plus minus 5 times the -5/4. So it would end up the same way. If you solve for y, you get the y-intercept of 13/4 and a slope of -5/4, okay? And just to show that, I'm going to do it with the other point, the same steps, but now I'm using the same m, which was -5/4, but I'm going to use the point x is 5 and y is -3. So we'll show it that way, and then we'll show it by solving for y and show that you get the same thing. So if you do it with the other point, this is what you get, but then if you solve for y, you get the same thing, see? And so what does that look like? Well, let's plot it. And notice I have a plot here, but I have to write the show, or it won't actually show up. So as a -5/4 slope, and notice I went from 0 to 5, so I can see the x-intercept and the y-intercept. Now, the y-intercept is at 13/4. What is that? 4 to 13 goes 3 times into 1, so 3 1/4. There it is, 3 1/4. And if remember, this is 0.2, 0.4, 0.6, 0.8, and then, 2.2, 0.0, 2.2, 2.4, 2.6, 2.8, and 3.0, right? So that's 3.2 and a little bit more, so 3.25, right? And then the x-intercept is whatever this is. Let's see, 2.6-ish. Is that right? If you plug in y equals 0, do you get x equals, that's what you get. So let's subtract -13/4, divide by -4/5. You're going to multiply by positive 5, divide by -5/4. You're going to multiply by -4/5. So it's going to be 13/5, and that is 2.6. Yeah, it is. So that's the line, and that's the equation, and there you go, done. All right, let's get rid of that show. Just keep the safe space. Okay, number 2. Given, let's read it down here. Given that the line is 4x minus y equals 2, find the x and y intercepts. And again, to do that, you solve for y when x is 0 to get the y-intercept, and you solve for x when y is 0 to get the x-intercept. Just because it's not in y equals mx plus b form doesn't mean it's not a line. How do you know if it's a line? If the x's and the y's are only to the first power, x to the 1, y to the 1, right? That'll give you a linear equation or a line when you graph, right? Please excuse my allergies. And so what we did was we said, okay, let's solve for y just to get an mx plus b form. Let's solve for y when x is 0 to get the y-intercept, but we can see that in mx plus b form. And let's solve for x when y is 0, and then we're going to plot it. What are we plotting? 4x. Well, apparently 4x minus 2 is what you get when you get to solve for y. So number 2, right. So y equals 4x minus 2. So the y-intercept is -2, and the x-intercept is a half. Now, you could have done that in your head, set y equal to 0, solve for x, add 2. You get 2 equals 4x divided by 4. You get a half, yeah. So when you graph it, it's going to hit the x-axis at 1/2 and the y-axis at -2. So let's show that. And there it is. So it hits the x-axis at 1/2 and the y-axis at -2. So there you go, perfect. So there's your line graphically, there's your line algebraically, and there's your x and y intercepts. And of course, if we're writing this is a point when x is 0, so 0 comma -2, and there's a point when x is 1/2, so so 1/2 comma 0 is the point that it hits the x-axis, so the x-intercept. The x-intercept is a point, right? So if we write down a point in parentheses with an x and a y coordinate. All right, there you go. That's number 2. Let's get rid of this plot. And take a look at number 3. All right, so given these two lines, again, they're lines because x and y are both first degree, right? Or at best first degree. What if x is missing? If y equals a number, you got a horizontal line. What if y is missing? If x equals a number, you got a vertical line, but it's still a line, right? Anyway, so are these two parallel, perpendicular, or neither? Well, if you knew the slopes, if you got y alone, you use this, see the slopes. If their slopes are equal, we got parallel lines. If the slopes are negative reciprocals of each other, you got perpendicular lines. Otherwise, well, there's no special relationship, right? So let's do that. Let's show each equation solve for y, so we can get mx+b form, and then we're going to plot it. Let's see what it looks like. I might as well put the show in here right now. All right, so number 3. All right, so notice they have the same slope, right? So they are parallel. Look at it. And the only difficulty here is what if they have the same y-intercept? What if this also worked out as -2/3 x plus 2? Then I guess you could say they're parallel, but they're also really overlapping. So if you wanted to solve a system of equations where these two lines don't intersect, there's no solution. Or if they overlap, there's infinitely many solutions. That's just as bad. You want a unique solution when you're solving a linear equation, usually one answer. Linear equation, one answer, quadratic at most 2, cubic at most 3, like that, right? Okay. All right, so that's number 3. Please excuse my allergies. Oh, boy. I'm redoing these videos in August. Yay. All right, so number 4. Same kind of question, but new lines. Now notice, well, look. These two lines don't have the same y-intercept. Y-intercept is 0, 2. Y-intercept is 0, 0. And they don't have the same slope either, so they're not parallel. -2/3 and +3/2. Well, aren't they negative reciprocals? Yeah, they are. So since y is alone, that was easy. And so I think all I did was graph it. Oh, we didn't talk about this aspect ratio thing. All right, so let's get rid of that. We'll talk about that in a minute. And again, notice if we're graphing 2 or more curves on the same set of axes in the same plot, you got to put them in a list with the square brackets. See the green stuff, the square brackets? Green stuff, square brackets. So I'm graphing 2 lines, right? All right, so let's graph that. This is number 4. And here, it doesn't look like they're parallel because, but that's because the aspect ratio is weird. My screen, you got to think about your computer screen. I'm going to make up some numbers. It's like 6,000 by 4,000 pixels, like 6,000 pixels wide. It's stretched horizontally, so it doesn't look right. So I'm going to tell Sage to keep that in mind and replot with an aspect ratio of 100%. That's what that means. So it compensates for the resolution on your screen. And so there you go. So that's more like what it looks like. So maybe I should have talked about this a little bit more. Without the aspect ratio, right? Hello, come on, tonight. My mouse is acting up. Bluetooth, stop. Okay, look at it this way. you can tell the aspect ratio is off because notice 1 unit on the x-axis is way longer than 1 unit on the y-axis, right? That's not what you would usually draw when you draw this by hand, right? So that's what aspect ratio does for you. It makes it look more like what you would do by hand, compensating for the resolution on your screen. And so now 1 unit on the x-axis looks about the same length as 1 unit on the y-axis. So that's so now look at it when you graph these two, a slope of what was it, negative 2/3 and positive 3/2, or vice versa? What the heck was it? It's negative 2/3 and positive 3/2, right? Do give perpendicular lines. There you go. And we did have y-intercept 0 and y-intercept 2, so perfect. That's it. Nice. All right, perfect. Very nice. Let's get rid of that show to save space. All right, number 5. Find a line containing the point 1, negative 2, but perpendicular to x equals 3y, x plus 3y equals 6. All right, so what does that mean? Well, if we solve x plus 3y equals 6 for y, let's just show that much. We find the slope of the line, right? So the slope is negative 1/3. But I want another line, a different line that goes to the point 1, negative 2. That's not this point. If you look in 1 for x, you get 1 times negative 3 is negative 1/3 plus 2 is 1 2/3. That's not negative 2. So I want a line that's perpendicular. So the slope would be the negative reciprocal of negative 1/3, which is flip it over 3, change the sign positive 3. So the m is 3, but the x1, y1 is 1, negative 2. So that's what we did. We did y minus y1 equals m times x minus x1, and we solve for y. Well, actually, this is the equation, and then this is the equation solved for y, so it's an mx plus b form. All right, so y minus y1, how do you subtract? You never do. You add the opposite, y plus 2, x minus x1, so x minus x1 would be x minus 1 times the 3, so there you go. And if you solve for y, well, let's see, all you have to do is subtract 2. And there it is. So it's going to be perpendicular to this line because the slope is a negative reciprocal, and it's going to include 1, negative 2. So if you plug in 1, you get negative 2. Yep. So then I graphed it, and again, I needed the aspect ratio to be 1. And, just for fun, I figured out where they intersected since they're perpendicular, they intersect. So one is negative 1/3 x plus 2 equal to 3x minus 5. That's where they intersect. And then let's plot it with the aspect ratio thing on, because it was without it wasn't looking perpendicular again. And there it is. Okay, so where do they intersect? When x is 2.1. 2.1 right there. And then we could figure out the y if you want. 2.1 times 3 is 6.3 minus 5 is 1.3. No, that's wrong. 2.1 times 6 is 6.3 minus, wait, something's weird here. That looks like 2. Oh, they intersect here. Okay, so that's 0, that's 2, that's 1, that's 1.5, less than 1.5. 1.3, yeah, that's about right. Okay, there you go. So that's this line in mx plus b form, so we got the slope. Then this perpendicular line would have a slope of 3 through the point 1, negative 2. Looks like that. Graph this, they intersect here, and it looks like that. At the point 2.1 for x and 1.3 for y. There you go. Perfect. All right, hope that was helpful. Enjoy your homework.